pretty much the whole day, but try to focus on the afternoon. We've definitely gone over a lot of varied topics, from argon to your less volatile calcium and sodium, background to hydrogen and water, and then finally the plasma. So almost anything goes, I'd say.
And anyone that's speaking, feel free to start your webcams.
So let me ask George a question about these magnetic anomalies. Since the last talk was on magnetic anomalies, and Zoo, this would be for you too, but one of the things that always struck me about the observation of the depleted OH, okay, that's always been assumed to be because the ions didn't get to the surface. So there's less implantation. Is that true, George?
Yeah, I suppose so. But in the end, whether it's because they're, well, I mean, yeah, they're not reaching the surface is the best conclusion I could come up with. And I mean, there was more than just the hydroxyl as, or lack thereof, rather, as a piece of evidence. There was a study that I published the same year, actually, just before that, using Clementine data, and this was relating it to nanophase iron creation, and I was seeing this the way that the spectra was behaving was indicating that the lunar swirls were just really not creating a significant amount of nanophase iron as they do elsewhere across the lunar surface, and especially at the dark lanes. And this also could be attributed to that protons were not getting in there and sputtering and or reducing the surface.
Right, so I thought that was really interesting, really cool, but the thing that bothered me about it is, okay, so what you've really done is you've choked off the local source, the magnetic field, basically blocked the local production of OH and, let's say, water. But yet, we know that if there's water migrating at latitudes moving upwards through its random motion across the surface as it hops along, you know, a la Butler and Kreider and von Drak, that should be moving across that volume as well. So I was surprised that by stopping the local source, you got such a big change, a noticeable change, given that you have, in some sense, external sources that are integrated and, you know, sort of non-local sources hopping across your observable volume as well. I mean,
would it be would you expect it to be landing there? I mean, I'm not really sure. Are the species neutral that are hopping along?
Yeah, it would be the same hopping water that you might get, you know, like as you get in some of these models where, you know, water is released and hopping along the surface. This would be just a neutral water, and then, you know, it would photodissociate into OH and also coat that surface as well. So really there's two sources in that.
Right, and I mean,
one is,
well, I'm sorry, go ahead.
Well, you know, there's the local generation, but then there's also water and OH moving across from all that created from all the external sources. I was just surprised that I thought the latter might inundate, so to speak, the signature of the local source, but it appears not to.
So I mean, so another thing that the magnetic anomalies can't filter out, like with respect to maturing the surface, because, you know, the swirls look like they're immature. It can't filter out micrometeorites. So one of the big conclusions of the work of this work was that it was really just pointing to the solar wind ions as being the dominant force in space weathering, at least at the moon, as being like the major agent of spectral space weathering anyway. I guess then I would say maybe that's the same effect that's going on with the hopping species, is that really it's the solar wind implanted ions that are the largest thing responsible, at least at most latitudes, or yeah.
Right. Well, and I wonder if their observation says something about the external sources. Maybe they're not as big as people think. Catherine Niche has a comment here. Is there, quote, less OH in the swirls compared to, say, fresh ejecta blankets or landslides?
I haven't been quantifying it. So all I really do is compare things that are like physically adjacent to each other. So I'm trying to think here now. I actually don't remember if we tried to look at the comparison of like a fresh impact crater in a swirl and see what the difference in, we must have done that. I just can't remember. I'd have to look it up. Yeah, sorry, that's all I have for that.
Okay. Well, Dana Hurley says alternately, maybe there is no hopping. And so I'm not sure what that means. I mean, I was thinking of the hopping water.
So, I mean, the hopping is it's just a thermal mechanism that's driving it.
Yep, it's just a thermal random sort of accommodation to the surface, so it's hopping along at whatever the local temperature is, but there's just generally a general diffusion from lower latitudes to higher latitudes. But that neutral water should sweep right across the magnetic anomalies and really be unaffected by the magnetic field. So there's both a local generation of water and a non-local sort of flow, if you will. And I was just surprised that the magnetic anomaly, that the reduction in the 3 micron signature was so pronounced, meaning that the local source is pretty strong.
Well, hey, maybe the polar nature of the water molecule is enough. Carly?
Yeah, we've got a couple of questions here, and this is a really interesting discussion, and I wish we all had resolution, but they are the sorts of questions that you know, the people who are working on really tightening the thermal removal and really getting more quantitative analyses out of the MQ results are going to be important. But Shuai had a question concerning some of the textural issues that Dana Hurley had raised, and I think Rosemary had talked about. So why don't you go ahead and ask your question.
So based on what we observed with the MQ data from morning to noon data at the Volatiles perclastic deposits, then we found that either on the morning or both on the morning and on the moon data shows the hydration status is like at least 5 to 6 times higher than the rest locations at the same latitude. So is it possible, like either you have like endogenous water there, like OH, and it's easier to accept additional H from like HOH, and then it shows highly hydrated, or it's because like because it's glasses, so it's very smooth. It lacks of net charge, so it's easier to accept solar wind implantation and form additional hydroxyl. So that's my question.
Who's it aimed at? At Dana?
What?
Yeah, well, Dana addressed some of it, and so did Rosemary earlier. It's basically what texture does to the ability to form OH. And one of the things you're always interested is with pyroclastic glasses, you have the smooth glass, whereas typical agglutinitic glass is not smooth. So does that just physical character affect, can you distinguish that in terms of all other things being equal, would you expect one or the other to have more OH be formed? That makes sense? And I guess Rosemary was the one that raised it, but not so much with OH. She was talking about, I think, sodium or sulfur. But she did point out that the character of the surface had an important effect. I see Dana's typing. Maybe she has the answer.
Typing furiously.
Yeah, Dana is saying, my understanding is that the OH production is facilitated by defect sites. Now, I will, one thing to address, though, is I think a couple talks talked about when you have small particles, the smaller the particles, the greater the surface to volume ratio. You have more exposed surfaces. And you think of it as a fractal. The smaller you go, the more surface area you have. And you just wonder if this is, given that all the interactions happening at the surface, the more surface area you have, the more chemical activity you might have at the surfaces. So roughness counts, I would think.
So you could just scale it with that.
Yeah, but it's very hard to explain, like, per class topology's location, both morning data and noon data shows like 5-6 times higher than other locations at the same latitude, no matter what the materials they are.
Well, but then it may be endogenous. Good.
Yeah.
Okay.
Yeah, I think Gordon Chin has a question here. It seems that everyone now has models with pile-up of molecules atoms at the Dawn terminator. George Kramer just cited, Michael Poston modeling, Shuai Li, MQ data, Graves model, Graves model for Argon Exosphere. Does the group think that this is a consensus process result in lunar volatile transport processes? And I think that's a great question. I was thinking about posing that this afternoon, or earlier this morning. Yeah, do we think diurnal effects are real now? I remember people always wondered about the sunshine and all result. And, I'm a believer. I mean,
I am a zealot even. I am a
zealot.
believer in, yeah.
All right, good. We need more zealots. So the person actually, I think the M-Cube folks would be the best to ask. Carly, I'm glad you're here. I think in your talk earlier today, you folks saw effects going on at the terminator as well. I think it wasn't the highest order effect. It was latitude and material composition, but number 3 on your list was a slight increase at the terminators. So that would be, if it's a terminator effect, that would be a local time diurnal effect. Do you agree that there's a diurnal effect?
I think you had 2 questions in there. Yes, we agree
Well,
with the diurnal effect.
Well, no, you listed, I think in your talks today, you guys listed a number of processes that control the OH on the surface. And you listed them, I think I remember one view graph, there was an ordering of the most dominant effect. And latitude was clearly a big one. But I think number 3 on your list was a pile-up at the terminator. I just wanted to confirm, A, that was something that you did observe, and B, do you think that there's a diurnal effect or a local time effect?
To answer the first, the terminator, we can't see, right at the poles, and I think that was either the neutron or the LAMP data that saw the peak right near the terminator. But in Shuai's data, he eliminated that because he didn't believe it.
Because the data signal-to-noise ratio is too low at a polar region. But if we take that into account, if we believe it's true, it will be very consistent with, I think it's Gregory's modeling work. It's like it drops up at around 80 degree to 90 degree. So that's why we must get it. We're not confident about that. And for the diurnal change, as I mentioned, it's if the latitude less than 60 degree, you do observe that diurnal change. But if beyond 60 degree, sounds like it's no change at even from morning to noon, noon to afternoon.
Yeah, that was that sort of big bullseye. Remember that I think tomorrow.
Right. Okay.
Actually, yeah.
And so you confirm that. You think you see that in the M-Cube data as well?
Yes, we got that data.
Okay.
Yeah.
All right.
When do you believe your data? If somebody else confirms it, you believe it.
Okay. Well, that's good. That means that that there is probably a diurnal effect.
Well, we could both be wrong, but you're right.
Let's see, I think there's a chat on the chat side of the house here. Let me just read what's been going on. Let's see, Dana Hurley says here, and I'm kind of picking up mid-chat, migration and cold trapping produces a dawn enhancement. Brian Butler says, agree with Dana. For that kind of model, dawn terminator pileup is unavoidable. And then Dana says, to get increases on both terminators, you need an in-place temperature-dependent retention. So, yeah.
Or I couldn't possibly right now.
This is Everett Gibson. I'd like to remind people that on Apollo 17, we left the mass spectrometer on the surface of the moon, the LACE experiment of John Hoffman's. That mass spectrometer did show variations, but not the large amounts that you're talking about. And that is a ground truth data point. It detected hydrogen, helium, neon, and argon trace levels of methane, ammonia, water, and CO2.
Right. That's right. Let's see, I think Dana says here, so if both terminators are the same, you probably don't have migration. If Dawn has more, you have migration. Not sure I follow that, but...
Maybe it depends on which side of the terminator you're looking at. So I mean, if it has to be an illuminated side of the terminator, then at dusk you're looking at the point where it's just cold enough that hydroxyl and water is going to start sticking, and then as soon as you get into that cold regime, it could be steady state all the way. But when you get to the dawn terminator, and again you're looking at the just lit up part, that's when the hydroxyl and water is just taking off. So it could appear like there's more. Did that make sense?
Yeah, possibly.
That's why the talk about looking at the nighttime side was fascinating with LAMP. Fascinating to me, I mean.
Let's see, Michael Poston says, Everett, didn't the lace oversaturate quickly each day? So I believe was an issue. Also, I think the water observations in particular were tricky because I think it was getting contaminated by the LEM, as I recall.
That's correct. Every time there'd be something happening in the LEM, they would notice it. They also noticed it every impact that occurred on the surface from every other rocket body that slammed into the moon during that period.
Okay, So it detected impact vaporization.
Yes, it also detected a few anomalous things that are still trying to be sorted out what they might have been.
Right. Yeah, one of the issues at the LADI SDT is I think Dick Hodges, after all these years, sort of says he's not a strong believer in a lot of the molecular species detected by LACE. And again, that made the case for why you needed LADI even more, because if you got rid of the molecular species, now you're down to like 5 total that we know about the moon, and all the rest of them are sort of upper limits.
Well, it is a ground-based data point that we have.
Right. Let's see, Rosemary Killen. Okay, Rosemary Killen's writing to Dana here. Dana, what about loss of adsorbed volatiles by micrometeoritic vaporization and sputtering on the night side? So this may be a separate conversation here between those two. Let's see, are there any other topics? Michael, did you have any topic that stuck out in your in listening today? I actually had one for Andrew Collette. Is Andrew still around? I was wondering how his impact studies, he's looking at impacts, how they compared with the Centala 92 paper. And I know that when we do exospheres, that's me. When we do exospheres, we rely on that Centala paper. It's almost like our Bible in terms of impact vaporization. I was wondering how closely his results matched some of that work. Right? Andrew may have jumped off, though. Yeah, it looks like he did. Okay. So it looks like Michael's phone went dead. Let's see. Oh, and looks like we've reached our 20-minute of discussion. George, you want to close it out for today?
Okay. I guess I want to thank everybody for attending this session, both of these sessions. This was fantastic. This is my favorite day personally. I don't mean any offense or anything, but today has been just awesome for me. And it had nothing to do with me giving a talk, believe me. But anyway, yep, that's I guess all there is to say. And everybody have a nice evening, and hopefully we'll see everybody and plus some tomorrow.